Hi everyone, welcome to the course on chemistry. In that we are discussing about electrochemistry. So in previous video we have studied the working of Daniell cell and the electrode potential which is developed during the process of conversion of chemical energy into electrical energy. And we have seen how does the electrode potential is calculated with respect to an reference electrode, and that is by using standard hydrogen electrode we will determine the electrode potentials of other elements. And we have seen the working of standard hydrogen electrode, and by using that standard hydrogen electrode we will calculate the standard electrode potentials values of the other elements. So let us consider the example where I need to find the electrode potential of copper. So I have immersed the copper in copper sulfate solution, and this will connect it to hydrogen electrode. So this is hydrogen electrode and this is copper electrode dipped in copper sulfate solution. Now they are interconnected by salt bridge. ಎರಡು ಒಂದಕ್ಕೊಂದು ಕನೆಕ್ಟ್ ಆಗ್ಯಾವ ಯಾವ ರೀತಿ by using salt bridge. ಈಗೇನಾಗುತ್ತೆ ಇಲ್ಲಿ, what does the reaction takes place? Here this Cu, it will gains the two electrons and becomes Cu. ಇಲ್ಲಿ Cu ಏನಾಗುತ್ತೆ ರೀ, Cu plus 2 ions ಇರ್ತಾವ. In solution there is a presence of Cu plus 2 ions. Those Cu plus 2 ions will gain the two electrons and gets reduced to Cu, and hence here the reduction will takes place. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ರೀ, reduction ಆಗುತ್ತೆ, and hence it will acts as cathode. ಇದು ಏನಾಗಿ ಆಕ್ಟ್ ಆಗುತ್ತೆ, cathode ಆಗಿ ಆಕ್ಟ್ ಆಗುತ್ತೆ. Okay, and at this side the hydrogen, it will loses two electrons and becomes H plus. ಇಲ್ಲಿ ಏನು ಫಾರ್ಮ್ ಆಗುತ್ತೆ ರೀ, H plus ions formation ಆಗ್ತಾವ. Hydrogen gas is passed here and that hydrogen will gives H plus ions along with the liberation of two electrons. Those two electrons will flow through this wire and they will get moved to this cathode, and there the copper gains the electrons and the flow of electrons takes place in this direction. So the flow of current will be in this direction, that is from cathode to anode the flow of current takes place, and from anode to cathode the flow of electrons will takes place. During this flow the potential is developed between these two, and that potential difference developed will be 0.34 plus 0.34 we will indicate, and here the copper is reduced, and hence the reduction potential of copper will be 0.34 volt. That much potential difference is produced, and this is how we will calculate or we will determine the electrode potential of the copper by using the hydrogen electrode. Okay, so this is the standard electrode potential value for copper, and this can be represented by in this manner. Okay, platinum bar H2 bar H plus two vertical lines Cu plus 2 bar Cu. Okay, so it is the electrochemical representation for this cell. Now in the similar manner we will calculate the electrode potential, standard electrode potential of the zinc, again by connecting that with hydrogen electrode. Remember here the solution concentration is 1 mole per dm cube, that is molarity of the solution is 1. Okay, and temperature is 298 Kelvin and 1 atmospheric pressure, that is also given as 100 kilopascal. So standard, at standard conditions we are calculating the electrode potential of the elements, and hence the values that we have determined are standard electrode potential values. Okay, and now Here for this reaction, the Zn, it will loses 2 electrons and gets oxidizes. So here oxidation will take place and it will act as anode. And the hydrogen ions, they will gain the electrons and hence they will get reduced to hydrogen gas and hence it will act as a cathode. So in this manner, the oxidation and reduction takes place. Again, when it loses, zinc loses the electrons will flow and there will be formation of electrode potential and it will produces 0.76 volt. And here the value of this will be represented as minus 0.76 volt because that is produced due to the oxidation of zinc, and in voltmeter it will show 0.76 only, okay, but you have to write it as minus 0.76 because there the oxidation takes place and here you have determined the oxidation potential, okay. So here we will write it as minus 0.76. So this is how we can determine the oxidation potential, or in general we can say the standard electrode potential for different elements. Now the positive value of standard electrode potential in the first case indicates that Cu plus 2 ions gets reduced to more easily than H plus ions, okay. And negative value of standard electrode potential in the second case, that is in zinc, okay, it indicates hydrogen ions can oxidize zinc. Hydrogen ions ಏನು ಮಾಡ್ತಾವು zinc ಅನ್ನು oxidize ಮಾಡ್ತಾವು. ಇಲ್ಲಿ first case ಒಳಗೆ copper ತಗೊಂಡಾಗ ಏನಾಗುತ್ತೆ Cu plus 2 ions they will get reduced, okay, means they will oxidizes H plus ions and itself reduces to Cu plus 2 ions. ಇಲ್ಲಿ ಸೆಕೆಂಡ್ ಕೇಸ್ ಒಳಗೆ ಜಿಂಕ್ ತಗೊಂಡಾಗ ಹೈಡ್ರೋಜನ್ ಅಯಾನ್ಸ್ ಏನು ಮಾಡ್ತಾವು ಜಿಂಕ್ ಅನ್ನು ಆಕ್ಸಿಡೈಸ್ ಮಾಡ್ತಾವು. ಸೊ ಹಿಯರ್ ಫಾರ್ ಡೇನಿಯಲ್ ಸೆಲ್ ವಿ ಹ್ಯಾವ್ ಟೇಕನ್ ದಿ ಜಿಂಕ್ ಅಂಡ್ ಕಾಪರ್. ಈಗ ನಾವು ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಪೊಟೆನ್ಷಿಯಲ್ ವ್ಯಾಲ್ಯೂಸ್ ಅನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿದ್ವಿ ಯಾವುದಕ್ಕೆ ಕಾಪರ್ ಮತ್ತು ಜಿಂಕ್ಗೆ. ಈಗ ನಾವು ಡೇನಿಯಲ್ ಸೆಲ್ ತಗೊಂಡಾಗ ಅಲ್ಲಿ ಏನಿರುತ್ತೆ ರೀ, ಹಿಯರ್ ವಾಟ್ ವಿ ವಿಲ್ ಗೆಟ್ at left electrode zinc is there and at right electrode the copper is there. Oxidation and reduction takes place and the EMF of that Daniell cell will be calculated by using the standard electrode potential values. How you will calculate that? E0 cell standard electrode potential value, that is EMF of the cell, is equal to standard electrode potential at right hand side, standard electrode potential at left hand side. Remember, right hand side you have to take always cathode, that means reduction, whatever metal is going under reduction that you have to consider, and left hand side you have to take anode, you can say E cathode minus E anode. So here reduction of Cu plus 2 ions will take place and hence the reduction potential value will be 0.34 minus at left hand side zinc is there and its potential value is minus 0.76 volt. So 0.34 minus into minus plus 0.34 plus 0.76 will gives 1.10 volt. So that you have already know the Daniell cell will produces the voltage of 1.10 volt, and here we will theoretically calculate that value by using this formula. For that you should know the standard electrode potential values. ನಾವು ಇದನ್ನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕಂದ್ರೆ ನಮಗೆ ಏನು ಗೊತ್ತಿರಬೇಕು, ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಪೊಟೆನ್ಷಿಯಲ್ ವ್ಯಾಲ್ಯೂಸ್ ಗೊತ್ತಿರಬೇಕು. ಓಕೆ, ಸೊ ದಿಸ್ ಇಸ್ ಒನ್ ಆಫ್ ದಿ ಎಕ್ಸಾಂಪಲ್ ಟು ಡಿಟರ್ಮೈನ್ ದಿ EMF of the cell by using the standard electrode potential values. Then here are the certain elements and the standard potential values of those elements, and you can see, so fluorine, it will gets oxidized to 2F minus, means it will undergo the reduction by taking the electron, it will oxidizes, so it is the strong oxidizing agent. ಬೇರೆ ಎಲಿಮೆಂಟನ್ನು ಇದು ಏನು ಮಾಡುತ್ತೆ ರೀ, ಆಕ್ಸಿಡೈಸ್ ಮಾಡುತ್ತೆ. ಆ್ಯಂಡ್ ಇಟ್ಸ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಪೊಟೆನ್ಷಿಯಲ್ ವ್ಯಾಲ್ಯೂ ಇಸ್ +2.87. As we go down the group, the stronger reducing agent, that means if we consider F and Pb plus 2 is stronger reducing agent than F minus, and Cl minus is stronger reducing agent than Pb plus 2, and H2O is stronger reducing agent than Cl minus. So down the group, the reducing power of these elements gets increases, and lithium is the strongest reducing agent since its value is lowest. And as we move above, then the oxidizing power will increases, and hence fluorine is a strong oxidizing agent. Lithium is weak oxidizing agent. That means lithium is the strongest reducing agent and fluorine is strongest oxidizing agent. Okay, so remember that. And here I have mentioned only few elements, and you can refer the NCERT book where more number of elements are given and their standard potential values are also given. And here you can observe the standard electrode potential values of the hydrogen is 0. If the values are in positive, then they will act as oxidizing agents, and if the values are in negative, they will act as reducing agents. First, what does reducing agent means? Reducing agent anta helidrenu? Reducing agent is something which reduces something else. ಬೇರೆದನ್ನ ರೆಡ್ಯೂಸ್ ಮಾಡುವಂಥ ಏಜೆಂಟಿಗೆ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ, ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್ ಅಂತ ಹೇಳ್ತೀವಿ. ದಟ್ ಮೀನ್ಸ್ ಇಟ್ ಶುಡ್ ಗಿವ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಟು ಇಟ್. ಅದು ಏನು ಮಾಡಬೇಕು, ಎಲೆಕ್ಟ್ರಾನ್ಸನ್ನು ಕೊಡಬೇಕು. ಸೊ ಎಲೆಕ್ಟ್ರಾನ್ ಡೋನರ್ ಈಸ್ ಸೆಡ್ ಟು ಬಿ ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್. ಮೀನ್ಸ್ ಇಟ್ ಶುಡ್ ಅಂಡರ್ಗೋ ಆಕ್ಸಿಡೇಷನ್. ಅದು ಏನಾಗಬೇಕು, it should undergo oxidation and it will loses electrons. That means it gives electrons to other element and it will reduces that element. ಬೇರೆ ಎಲಿಮೆಂಟ್ ಅನ್ನ ಏನು ಮಾಡುತ್ತಾ, ರೆಡ್ಯೂಸ್ ಮಾಡುತ್ತಾ. ಮೀನ್ಸ್ loss of electron. If any substance loses the electron, it will act as reducing agent. Okay, and if any species will gain the electrons, then it is said to be oxidizing agent. Electron ಅನ್ನು ತಗೊಂಡ್ರೆ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟ್, ಕೊಟ್ಟು ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್ ಅಂತ ಹೇಳ್ತೀವಿ. ರಿಮೆಂಬರ್ ದಿಸ್. And standard electrode potential for fluorine is highest, and hence the fluorine has the maximum tendency to get reduced to fluoride ions, and therefore fluorine gas is the strongest oxidizing agent, as I have already mentioned it. And weakest reducing agent, fluorine ion ಏನಾಗುತ್ತೆ ಇದು, ಫ್ಲೋರೈಡ್ ions, they are strongest oxidizing agent and weakest reducing agents. And lithium has the lowest electrode potential, and hence it is the weakest oxidizing agent, but it is the most powerful reducing agent in an aqueous solution. Okay, so remember these points. Nernst equation. We have determined the standard electrode potential values. That is, when the concentration of solution is 1 molar and temperature is 298 Kelvin and pressure is 1 atmosphere. We can maintain 1 atmosphere pressure and the 298 Kelvin temperature. But for different concentration of solutions, what would be the electrode potential value? Suppose ಬೇರೆ ಬೇರೆ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇತ್ತು ಅಂತ ಹೇಳಿದ್ರೆ, ಇಟ್ ಇಸ್ ನಾಟ್ 1 m ಇಲ್ಲ, 2 m ಇತ್ತಪ್ಪ, 3 m ಇತ್ತು, or 0.5 m. If such kind of concentrations are given, then how to measure the standard electrode potential value? That we should know. And this can be given by a scientist known as Nernst, and that equation is known as Nernst equation. And this Nernst equation is given by E mns bar m is equal to E minus mn plus bar m minus RT divided by NF ln concentration of M divided by concentration of metal ion. Here M means metal and Mn plus means concentration of metal ion. Okay, so here also electrode potential of the metal ion at a given concentration, and this is standard electrode potential value of that metal. Okay, so here the concentration of solid metal is taken as unity. One solid metal the concentration ಏನಂತ ತಗೊಂತೀವಿ unity ಅಂತ ತಗೊಂತೀವಿ 1 ಅಂತ ತಗೊಂತೀವಿ because there the concentration is maximum. Okay, it is not dissolved in any aqueous solution. If it is dissolved, then its concentration gets decreases, but here the metal, if it is present in solid state, its concentration is taken as unity. Other concentration 1 ಅಂತ ಹೇಳಿ ತಗೊಂಡ್ಬಿಡ್ತೀವಿ. Then what does this equation becomes? It will be like this. So here we will substitute 1 in place of concentration of metal since it is present in solid state. Okay, then here R is universal gas constant, T is temperature, N is number of electrons, and F means Faraday's constant. And here Faraday's constant value is 96,487 coulombs per mole, and value of R is 8.314 joules per Kelvin per mole, and temperature is in Kelvin, and Mn plus is the concentration of the species Mn. In Daniell cell, the electrode potential for any given concentration, we will write ECU plus 2 bar Cu is equal to standard electrode potential of copper minus RT divided by 2F ln 1 divided by concentration of Cu plus 2 ions. ಯಾಕೆ ಇಲ್ಲಿ ಹಿಂಗೆ ಬರಿತೀವಿ? ಇಲ್ಲಿ concentration of metal ion M ಇಲ್ಲಿ ಏನದರಿ copper and its value is 1, and Mn plus ಅಂತ ತಗೊಂಡಿದ್ವಿ. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ copper Cu plus 2 ಇದ್ದಿದ್ದು Cu ಆಗುತ್ತೆ. So we will write it as Cu plus 2 bar Cu, and standard electrode potential of Cu plus 2 bar Cu RT divided by NF. N means number of electrons, whether it may lost or gain. Loss ಆಗಿರಬಹುದು ಅಥವಾ gain ಆಗಿರಬಹುದು. ಎಷ್ಟು electrons gain ಆಗ್ಯಾವಿಲ್ಲ 2, and hence it is 2 and into F. And for anode, how we can write? That is for zinc. Here we will write the same. In place of Cu we will write the Zn, and there again RT divided by 2F, because it will loses 2 electrons, and hence the number of electrons involved will be 2, and again the concentration of zinc metal is 1 divided by concentration of Zn plus 2 ions in the solution. And now the cell potential, I want to find the cell potential for this Daniell cell. How we can calculate that? E cell is equal to E cathode minus E anode. Cathode side another copper, anode side another Zn. So substitute the electrode potential values of copper and Zn that are calculated by using this formula. If just ECU plus 2 bar C andre ಎಷ್ಟು ಅದರಿ ಈ formula ಅದ, substitute that, and Zn plus 2 bar Zn, it is equal to this value. So substitute those values in this equation. What you will get? E naught standard electrode potential of copper minus RT divided by 2F ln 1 divided by Cu plus 2 minus standard electrode potential of Zn plus 2 bar Zn RT divided by 2F ln Zn plus 2. Now on simplification, what you will get? I will take this standard electrode potential of Zn this side. Okay, so ECU plus 2 bar Cu minus standard electrode potential of Zn and minus RT divided by 2F, which is common in both the cases. In bracket I will write it as ln 1 divided by Cu plus 2 minus ln 1 divided by Zn plus 2. Now see this formula, ln M minus ln N. This is present in that form, log M minus log N, log M by N ಅಂತ ಅಂತ ಹೇಳ್ತೀರಿ. ln m minus ln n is nothing but ln m by n. So what you will get? You will get E naught cell minus RT divided by 2F ln Zn plus 2 divided by Cu plus 2. M by n formula use ಮಾಡಿದ್ರಿ ಅಂತ ಹೇಳಿದ್ರೆ 1 divided by Cu plus 2 divided by 1 divided by Zn plus 2. Zn plus 2 numerator ಒಳಗೆ ಬರುತ್ತೆ, Cu plus 2 will remain in denominator. And here E Cu plus 2 bar Cu and the standard electrode potential of Zn is nothing but what? E cell. Okay, that is E naught cell. Here standard electrode potential values are taken. So standard electrode potential minus RT divided by 2F ln Zn plus 2 bar Cu plus 2. Okay, so this is the formula to find the electrode potential or cell potential or EMF of this cell, that is Daniell cell. Now by converting the natural logarithm in above equation to the base 10 and substituting the values of R, F and T, we will get what we will get. R iddalli 8.314 hakri, T iddalli 298, F anta helidre 96,487. Then we will get E cell is equal to E naught cell minus 0.059, N anta helidre endri 2, or you can in general you can write it as N. Okay, but for Daniell cell it is 2, value of N is 2, so do 0.059 divided by 2 log Zn plus 2 bar Cu plus 2. So this is the formula to find the electrode potential at any concentration in ಬೇಕಾದಿರಬಹುದು. And here N is number of electrons, and for both the electrodes the loss of 2 electrons and gain of 2 electrons has been taken place. So totally the number of electrons involved will be 2, and hence it is taken as 2. Next, for another electrochemical cell, if we have taken nickel, which will gets oxidizes to nickel plus 2, and for Ag, where Ag plus gets reduced to Ag. In this reaction, how we can calculate the E cell, that is cell potential, that can be determined E cell minus RT divided by 2F ln Ni plus 2 divided by Ag plus 2. Here always at numerator the oxidized form will be written, and at denominator reduced form will be written, and hence the equation will be like this. Okay, remember. And here also 2 electrons are exchanged, and hence we can take the value of N as 2, and also if we substitute the value of R, T and F, we can write 0.059 divided by 2 ln Ni plus 2 divided by Ag plus 2. And for a general electrochemical reaction for the type AA plus BB gives CC plus DD, the nearest equation can be written as standard electrode potential value minus RT divided by NF ln Q, where Q is concentration of C raised to C, concentration of D to the power D divided by concentration of A and concentration of B to the powers of AB. Okay, so remember this formula, just simply remember these forms. Okay, 0.059 divided by N log oxidized form divided by reduced form. Okay, if you remember this, if they give any equation, you can able to find the cell potential value for a given chemical equation.